Okay, so question 5, we're talking about box plots. It says the time in minutes that a large group of students spend on exercise per day are presented in the box and whisker plot as shown below. Now, one quick hint when you're looking at HSC exams, understanding the format's pretty important. If they ever include a picture or a diagram or a chart, something like this, all that information above, it's usually just describing that picture. So it's kind of useless. It's still important to have a quick glance over because sometimes it'll have information or a word that you kind of need to understand what the picture is showing. But usually, if there is a big picture like this one, you can just read what's underneath. So in this case, we're looking at what percentage, so our answer is going to be percentage, of these students spend between 40 and 60 minutes per day on exercise. So we've got those numbers 40 and 60. Let's go straight to our graph and highlight 40 and 60. And it's pretty convenient. You can see that it matches up really well with these two lines here. Now, all you need to know about box and whisker plots for this question is that that middle box is always going to show 50% of the data. Okay, and to break it up even further, each of these quarters, right, each of these areas here is going to show 25% of the data. So if we're looking at one of those quarters, we are looking at 25% of the data. It doesn't matter that the boxes aren't the same size, it's just going to show how the data is spread, and that's going to be 25% in there. Okay. So, radial surveys, question 6. These questions always look a lot scarier than they actually are. Okay. So again, that little explanation at the top doesn't actually add anything to the question, it's just giving us the picture. So our actual question is in triangle AOB. So straight away, I'd be drawing the points A to O to B. So I know that I'm talking about that triangle there. And if you're not sure which one, I'll quickly color it in. So that one, okay, AOB. It wants to know what the size of angle, that's what that little witch's nose is of AOB. So again, that's if you were to draw from A to O to B, that makes this angle here. Okay, so to find that angle, we need to look at the bearing or the angle that each of these points has gone off on. And if you're in my class, something we did is we went out really early on in the year and we started from north. You can see that's the point labeled here. And then we each walked off from north at a different angle. And so it's used a lot in indigenous civilizations and older civilizations to kind of get like a map of the area and see how far they can walk without hitting something. Okay, so that first point B, you can see that it has a bearing of 51 degrees. Now that's 51 degrees from north, so we can draw that straight in. That's 51 degrees just there. And you can see straight away we've got part of that AOB angle. Now I need the other part, and these C and D points aren't really going to help me. They're just giving more of the picture. What I want to know is what this gap here is. So let's have a look at that line A, and it's coming out on a bearing of 300 degrees from north. So what you need to remember is that to do a Tony Hawk Pro Skater 360 flip, we are going around 360 degrees to do a full circle. Okay, to start from north and get all the way back to north, that's 360 degrees. So if I've come all the way around 300 degrees to get to A, then there must be 60 degrees left. And you see that by adding those two angles together, 60 plus 51, I'm going to get my 111 degrees. And that'll be answer B. They're trying to trick you with that answer A, okay? Because if you partially completed this question, you panicked a little bit and you got that 51 degrees and just circled that straight away, that's kind of what they're banking on there. But you can clearly see by drawing it on that you need that other gap. Okay, another big picture. We've got the Louvre Pyramid in Paris. and it has a square base with side length 35 and a perpendicular height of 22 meters. Now again, all of that information is shown on the picture. Possibly the only really important thing there is that it has a square base. You can see that by the little dashes that it does have on the picture. It does show that it's a square, but just making sure that you know it's definitely a square on the bottom. Now, whenever you're asked to do volume, okay, the first thing you want to do is run over to your reference sheet. Basically, most measurement, you'll be checking your reference sheet. Okay, and if you go to that volume category, there's two equations. We've got volume equals 1/3 AH, or volume equals 4/3 pi r cubed. Now, what you really need to remember is that pi is this magical irrational number that shows up when we're dealing with circles. So if there was something circular about our shapes, like a cylinder or a circle, an annulus, any kind of shape like that, like a pipe, then we'd be looking at something including pi. This is clearly nothing to do with circles, so we're not going to use the equation with pi in it, we'll use the other one. Okay. Now to find our volume, we need to know what A is and what H is. You can probably figure it out through a good guess that A is going to be the area of our base. So we know it's a square, okay? I can quickly draw it just so we have a rough idea. That's 35 by 35, okay? And the area of any rectangle, which a square is, we're just going to times those sides together. A quicker way, of course, you could say 35 by 35, or you could just say 35 squared. They're both going to give you that same answer of 1,225. So now we know that's the area of the base, we just times it by h, which is just going to be the height. And again, they've given that to us. If they wanted to make this a harder question and possibly use it in an extended response later down the track, maybe they'd give you some other measurements and get you to do maybe Pythagoras to figure out what that height is, but at its core, it's just using this formula. Okay, so the height, well, that's 22. So our volume is just going to be 1/3 times 1,225 times 22. And that should pop out an answer of 8,983.3, and it goes on for a bit. We can have a look at our answers, A, B, C, D, and clearly it's closest to C. Okay, and that should make you feel pretty confident if you get something super, super close. So getting to question 8, we have the top of a cliff that is 67 meters above sea level. You can see that's shown on there, so that's all good. The angle of depression of a buoy out at sea is 42 degrees. Now we actually need to draw that angle in ourselves because you can see that they haven't drawn that 42 degrees anywhere on our picture. Now what you need to know about angles of depression or elevation is that we always start as though we're looking out. So if you have your line of sight, you're looking straight out across the horizon, and then from there we're either going to draw up to do our elevation or down to do our depression, as though you're like lifting your head up or down. So in this case, we're looking down at 42 degrees. The most common mistake people make on a question like this is before all that red information is there that we just drew, they'll draw 42 degrees in here and then try and solve the question. And even if they do everything else correct, they're not going to get the right answer because that angle in there, it's not 42 degrees. It's actually the angle from your line of sight. So from there, we can have a rest of the read. We're saying how far is the buoy from the base of the cliff to the nearest meter. So we're trying to find this distance across here. We'll call it D, you could call it X, totally up to you. Now when I do an angle of depression question, I always start by drawing that line of sight, and you can see it's always going to make like a new triangle. And I just like to use that triangle because I find it a little bit easier. Okay, and you see that we've got an angle and we've got two sides. Now if you're ever dealing with triangles, and you have an angle and some sides, you know that we're doing trigonometry. Because trigonometry, again, by definition, is just like the measurement of triangles. So if we bump over to our reference sheet, okay, then you have a couple of options. What you need to realize here is that we've got this right angle. Okay, and we can draw a little right angle here as well if you like, but it's not super necessary. And whenever you have a right angle involved and you're looking at triangles, that's going to be the first thing that we looked at and the first thing on your reference sheet. It's that SOHCAHTOA. Now we don't actually have to remember SOHCAHTOA because they've actually written it on your reference sheet. I think it's in terms of A. Okay, and it says opposite over hypotenuse, and it will have that for each of the sine, cos, and tan. Okay, so you actually don't need to remember any of it because it's all there for you. So when we do this kind of question, we want to start with our angle, our 42 degrees, and we're going to look at what sides do we have in that triangle. Now I'll color it in blue so you know exactly what triangle I'm talking about, just that one there. And what sides have I got? Well, from that angle, I've got the opposite side, the side that is opposite that angle. And I also have the side that is adjacent to that angle, so next to it. The only other option is the hypotenuse, which is always going to be like the diagonal, the longest side, and it's always opposite that little box. So that's a really useful thing to be able to remember, just to be able to look at a right angle triangle and an angle and spot what sides have I actually got. So in this one, I've got the opposite and the adjacent. You look at your reference sheet, figure out which rule you're going to use, and you should get that it is tan. So all I'd quickly scribble down on my piece of paper is I'd write tan of that angle, so 42 degrees. That's going to be the opposite, so 67 over the adjacent, so D or X or whatever you called it. We have to do a little bit of solving to figure out what D is because that's our goal, that's our distance we want to find. So there's a couple ways you can do it. You could remember a shortcut, which is where if D is on the bottom, because this is actually a hard case, it just swaps with everything on the other side. So then you'd get D equals 67 over tan of 42. Pop it in your calculator and you're done. Another way to do that step that we just covered really quickly there, okay, is to say, right, well I know my equations, I just want to get D on its own. So to undo divide, I'm going to times D over here, okay, and then I want to get rid of that tan 42, so to undo times, you're going to divide. So you end up with 67 over tan 42. That's basically what we're doing, but if you just remember the shortcut of if you're doing SOHCAHTOA, you're doing trig, and you end up with the letter on the bottom, then you need to just swap it with everything on the other side. If you type that into your calculator, you should end up with 74.4 blah, 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 blah. Having a look at our answers, clearly it's closest to B. And I guarantee if you were to treat this angle as 42 and then try and do the problem, then one of these multiple choice answers would be that, but we know better.